Good morning, everyone. Today we'll move on to an interesting topic on purification of water. So, before we go into this purification of water, let me tell you how the water is classified. For example, uh, see how many of you have the habit of washing your clothes every day at home? Only very few people are doing this work daily at home. uh, when you while you're washing your clothes itself, you'll get to know about the quality of your water. That is whether the water is a hard water or it is a soft water, so that quality can be easily checked just by washing your clothes itself. See, when there will be a formation of lather, or if more, lather formation occurs in water, when the water reacts with the soap solutions or with the detergent, then that water is considered as a soft water. Whereas in the case of hard water, there won't be any lather formation, or sometimes it will take some more time to some more time for the formation of lather. So it is very difficult for the formation of the lather in the case of hot water. It is because of the presence of the calcium ions or the magnesium ions in the water, and these ions only causing the hardness of water. So when we remove these ions from the hard water, that water gets purified. We are able to purify the water just by remove these hardness causing ions like Ca2 plus ions or the Mg2 plus ions in water. Next we'll pass on to how are we going to detect qualitatively uh, uh, the water, whether the water is a hard water or soft water. So as a chemist, you should know the qualitative test for detecting the hardness of water. For example, if the water contains the calcium ions or the magnesium ions, it reacts with the EBT indicator to form the calcium EBT complex. So that calcium EBT complex is found to be wine red in color. See, whenever there is calcium or magnesium ions in water, it reacts with the EBT indicator uh, uh, around the pH of 8 to 9. In alkaline medium, there will be a formation of this complex, which is wine red in color. So this is one of the tests we do at a lab to detect the presence of the hardness causing ions in water. So this is the qualitative test. Next we'll see how are we going to remove the hardness causing ions from water. See, one way of removing the hardness causing ions like calcium magnesium ions from water is to just boil the water. So when you boil the water, all the calcium ion gets deposited, or gets precipitated in the form of calcium carbonate, or all the magnesium can be precipitated in the form of magnesium carbonate, and these can be easily filtered by the filtration process. Thereby we are able to remove the hardness causing ions from water. So by just boiling the water, we are able to remove the hardness causing ions from water. This is this one we daily, every day we used to follow this procedure. We follow this process at home. But in the another way of removing the hardness causing ion is, this is a suitable technique for the removal of the hardness causing ions. So the name of this process is called as demineralization process. So first of all, we should know what is demineralization and what is the instrument we use for this demineralization process. Demineralization means the water containing the hardness causing ions, not only the hardness causing ions, other unwanted ions, if it is there in the water, that can also be removed with the help of an instrument called a deionizer. So in the case of deionizer, when the water is initially, when it is passed through the raw water, that is hard water, the water containing the calcium or the magnesium ions, when it is passed through the cation exchanger resin, cation exchanger column, so there the cation exchanger resins are placed. So those resins are, absorb all the cations, and the water coming from the cation exchanger resin is free from cations. Then the cation free water is passed to the anion exchanger column, where all the anions are absorbed on the surface of the anion exchanger resin, which is kept in the anion exchanger column. Then the water which comes out from the anion exchanger column is free from anions. So that way we are able to remove the positively charged ions and the negatively charged ions, both the anions as well as the cations, from the water, and the outcome water, the final water which is obtained from this process is gets pure. It's a pure water. It doesn't contains any hardness causing ions. So this is an interesting process where we are able to remove all the hardness causing ions with the help of an instrument called the deionizer. So next we'll pass on to the advantages of using this method. See, even the highly acidic solutions or even the highly alkaline solutions can be used for this water treatment. Then very low hardness of water which is obtained by this method, it has a very low hardness. So these are some of the merits of using this technique. Then coming to the demerits, disadvantages of using this technique is, suppose if the water contains the iron or the manganese, it cannot be treated by this method, because the iron, it reacts with water forming the ferric hydroxide. So that ferric hydroxide is insoluble in water. It cannot be easily removed from the water. So this is an demerit of using, this is one of the disadvantage of using this, when we go for this technique. And the instrument is also, it is found to be highly expensive in this case. And then coming to the references part, I have referred these two books. One is Engineering Chemistry by Jain and Jain. Another one is Gavarikar. This is a polymer chemistry book. So when you go through this book, you get more knowledge on the purification of water. And I have shown you, or I have told, given you only the two methods like purification technique. Very few techniques I have given. So if you happen to see these books, you will get to know more methods regarding this purification of water. So thank you very much for listening to my lecture. Thank you very much.